Kaushika sir, shall I proceed with welcome?
Yes, sir. Yes, sir.
Good evening to all, and this is the 39th webinar from QCrete Readymix India Private Limited, and in association with ICI Mangalore Center. First of all, I welcome all the participants on this platform, webinar platform. And at the same time, I would like to welcome our today's resource person, Dr. Venkata Dilip Kumar. And he's a very knowledgeable person. So that's how we are all waiting for Dilip sir. We are all waiting to hear from you rather than me talking to all. And at the same time, I would like to welcome Kaushika sir and all the partners of this program, that is from QCrete organization. And once again, welcome to all. And let us enjoy this particular talk by improving and enlightening ourselves with great words of wisdom from Dr. Venkata Dilip sir. So once again, welcome to all, and would like to pass on the things to Kaushika. Thank you so much, sir. Kaushika sir.
Good evening to all. Thank you all for coming to this webinar. I just introduced Dr. Dilip Kumar Pasupaleti on this occasion before he starts his lecture. Dr. Venkata Dilip Kumar Pasupaleti sir, he's after having done his graduation, BE Civil Engineering from Osmania University, he went on to do his MTech from International Institute of Information Technology, Hyderabad. Then he went on to finish his PhD from International Institute of Information Technology, Hyderabad in Civil Engineering. And most importantly, Dr. Venkat Dilip Kumar Pasupaleti sir, he has delivered a lot of lectures, webinars, seminars, and he has done extensive work in the systematic analysis of residual strength and other things related to rehabilitation, and he has suggested remedial measures not only for ordinary buildings, even including heritage structures. That is what the lecture of today is about. Most importantly, he has helped many students to present their research thesis, and then he is guiding many PhD students also. Most importantly, he is a very humble human being, and he has agreed to deliver this lecture whenever we have requested him. He has smilingly agreed to come and deliver lecture for us. And we are thankful to you, sir. Today we are having the privilege of hearing from you. And once again, I welcome all of the audience here for this presentation, which is very interesting because there are buildings which are very old, and how to understand the residual strength and how to repair them, and all this will be dealt in detail by Dr. Dilip Kumar Garu. So welcome you, sir. Thank you.
Thank you so much, Kaushik Garu. My voice is clear?
Yes, sir.
Okay, great
Yes,
evening, everyone. In fact, it is my pleasure to share whatever the knowledge we are gaining at our research center. But before I start my webinar, I would like to thank ICI Mangalore section, Mangalore Center, and QCrete Readymix India Private Limited for giving me this opportunity to share the knowledge on heritage structures. Me and my colleague, Professor Profil, we started this Center for Sustainable Infrastructure and Systems in the view of trying to combine computer science knowledge and civil engineering knowledge. And we have found out certain amazing things about steel, concrete, and stone structures in a past duration of last 4 to 5 years. I don't tell we are experts in this area, but we have definitely begun our journey in understanding heritage structures. So my lecture today will deal with science, engineering, and rehabilitation of heritage structures. We've been done a lot of visual observations, NDT testing, material testing, and numerical model. But since heritage structures concept itself is a very big thing, I would like to limit myself into simple understanding and how did we come up with the numerical modeling. And the second one will also show you the current ongoing structure rehabilitation or renovation. Largely it's a conservation. So yes, I have already been given a small introduction. Thank you so much, Kaushik Garu. So I did Usmania University Engineering and Master's PhD from IIIT Hyderabad. But then the actual journey of my PhD was an absolutely amazing journey. And that is what has motivated to take up 3 fields. So outline of my presentation, this part, who has ever attended my previous lecture, this 2 slides I'll always keep, because it is also something which we have to think about. Science, engineering, and technology. And we'll see a little bit about ancient structures, what's the science, engineering, and certain facts about ancient structures, which we are in the journey of understanding. And I'll tell what kind of research we are trying to do here. And of course, a small conclusion. Definitely that I call, rather than a conclusion, it will be just a small 1-line summary. Introduction. I always love telling this about science because one of the most beautiful thing in nature, whatever you observe, is called it as science. And when we try to understand what it is, we just put it as a fact. So all the facts are actually the part of science. And your fundamentals of any human being, irrespective of whatever civilization has been, largely based on the observations. And if one can truly observe all the ancient structures, they can connect a lot of natural elements, especially the 5 elements. No subject will be missed in ancient structures. That's a beauty. Engineering, this and this both are same. Both the pictures are actually the same. One is natural, one is artificial. The human being has created and he has used from a basic understanding of science, and he has implemented for his own comforts. That's largely we call it as creativity. This has been science and engineering. I show you this example because dam is considered to be one of the largest, biggest, heaviest structure apart from the pyramids itself. Technology, even though technology might not be the part of ancient structures, but technology can be said as techniques. They had a beautiful mechanics techniques, which they might have used in construction of most of the temples or heritage structures. In fact, very recently when we had our visit to Thousand Pillar Temple and Ramappa Temple, I'm sure you'll know Ramappa Temple is recently added into the UNESCO. So we were trying to understand the foundation of that structure. It's amazing. So that's all about technique. So right now, using the current technology, can we decrypt the techniques which were used in construction of such temples is one thing which we are trying to use technology into. Technology is very simple. It's a simpler, faster, parallel, and robust. And management, I'll not get into this. This is largely about resources, demand, and distribution. Ancient structures. India has seen a lot of evolution of the structures. So let us see a little bit of science, engineering, and facts about Indian ancient structures. As I said, India has gone through various extreme cultural changes from the early civilization to the present modern day. And in the same way, the structures have also seen a lot of change, whether it might be from the east to west or from the north to south, based on the materials, based on the temperature, based on the geographical conditions. The structures have evolved. This might be one of the oldest structure. When we see such kind of structures in northeastern area, why we would like to have elevated structures? You can see the height of structures little. They are generally for simple is for the flood proof, waterproof. So any kind of animals or all kind of things. So they are raised platforms. So we can see a lot of houses, especially where there are land slopes or a floods or even lot of water flow. We see the elevated house in the even northern eastern places even till today. And the second thing, India is also known to be the one of the first country or first civilization where they have seen the development of colonies itself. And then came this completely stone structures, marble into pyramid, very much tapered into pyramid kind of shape. You can see the reduced section, and then Indo-Islamic uh, tradition or Indo-Islamic structures. Let's see in detail. So 3000 BC, or we believe it is more than that, 3300 BC to 1300 BC, Mohenjo-daro. This is one of the first civilization, and still there are a lot of unknowns in this civilization. And we know the first burnt brick was used in this civilization. First, okay, the first burnt brick was used in this civilization. And we also know that there was complete town planning. In fact, if we understand the urban planning these days, uh, and we see the town planning of Indus Valley civilization, we feel that that town planning which was used in Indus Valley civilization is much far better. The transportation is considered, sewage is considered, water treatment is considered, symphony system is considered. The reverse water system was also seen in the Indus Valley civilization, which we hardly see now these days. And then schematic cross section of those days for multiple usage of the house spaces. The schematic, it shows the spaces of those houses were used for multiple purposes, and the functional utility of that was also seen in 3300 years back. And we have a great paths for multiple people, and it can accommodate the whole societal in those days. And we also see the drainage system. In fact, Hyderabad is one of the old city, and Nizams were ruling, and before that, we were a lot of people who ruled the Hyderabad. And we have recently have seen there is a drainage system which was going and it across the Hyderabad, and it was built with granite stones and completely based on gravity systems. Of course, we know those are all systems were based on gravity. And then how did this evolution begin? Evolution of building methods and styles. The first, we call it as Dravidian style. We all should know the mid part of India, which is Deccan Plateau, which is very rich in granite stones, metamorphic and igneous stones, have lived to the Dravidian style. So largely the Andhra Pradesh, Telangana, Karnataka, in fact mid of Maharashtra, they'll all have a Dravidian style of temples or heritage structures. One of the most mesmerizing thing about these temples are, even there are a lot of videos online, you could actually see how could one have carved these stones. How could one have carved these stones? In fact, we've been spending a lot of time on how these temples have been carved from a single stone. Was there any no mistake while they're carving? So you can see that the accuracy of these temples seems to be 100%. And you can see this. Of course, this is based on wind and east and west direction, sunrises and sun sets. About those things have been completely considered into this. Apart from the magnetic field itself, the orientation of temples were placed in such a way that we have this good vibes. I'll talk about that vibes later, which are good for human health, especially when they're in this. This is Kailasnath temple at Ellora. In fact, just before beginning of this lecture, we were talking about some other person who was also trying to do a lot of research, Mr. Praveen Mohan. There are a lot of other professors who were also doing a lot of research on this. How could people carve so fine with accuracy from single stone? So there are a lot of mysteries behind this, and people still are struggling to understand or decrypt what could have been done in those days, or how many number of people would have worked on this site. So even if 800 to 1000 people would have worked, it would have taken at least 50 to 60 years to complete this project. So would those projects have actually been developed over a century of time, or would it been in a short period of time with some unknown technique which we are not able to decrypt these days? So those are all questions we have. So stone is a major building material, and largely they are rock cut, and we also see that they are pyramidical elevation and they are also multi-storied. And then we have a Nagara style, largely of granite as well as sandstone. Northern part of India has largely have this, and the best is we call it as bell-shaped towers. And we also have Visara style, which is of both mixed of Dravidian and Nagara style. So we have a lot of Visara style as well. So mid part of India actually sees the Visara style, which is of both Dravidian and Nagara. So with this evolution of Dravidian, Nagara and Visara, after the invasion of India, there is an Islamic style which was added to the Dravidian Nagara, and it became Indo-Islamic style. So when Indo-Islamic style has gone, we have a lot of lime and mortar which actually came into the picture, and this has given perfect shapes with a lot of lime and mortar. But if you see in the Dravidian, we have the similar kind of geometry, but made up of a single stone. But slowly, when it came to Indo-Islamic style, and then there was a lot of brick and lime and mortar which gave it to those shapes. We'll also see certain shapes domination. So it was largely called it as Persian and Islamic buildings, and it consists largely of arches and domes, and we call it as minarets, like Charminar, Qutub Minar. We have seen Taj Mahal, a lot of. So all these examples, which you are actually seeing as an example of these pictures, so all of these styles have been developed over a period of time. So these are all our Indo-Islamic style. And we have been able to understand the construction technique and the kind of stone, how this might have been built. We are able to analyze that, and we are able to understand all these Indo-Islamic styles. But the Dravidian style and a lot of temples in Tamil Nadu, there are a lot of mysteries even till today, which we'll see in short period of time. This is Taj Mahal, marked from the marble. And I'm sure I was actually talking about this picture with one of my colleagues in our research center. Then we were trying to model it, and we were so confused. How do we model this complex geometries of ancient structures? I will not be able to tell all the geometries, but I'll definitely add one. See, if you can see this, a small sentence for us to understand. The Hindu temple has a shikara, which we call it as Vimana or spire, that rises symmetrically above the central core of the temple. And these spires come in many designs and shapes, but they all have mathematical precision and geometrical symbolism. Now, why I have written this statement, most of my slides don't have statement, but this, we were trying to talk about mathematical and geometrical precision. So they are so symbolic. And once we decrypted this, we were able to model most of the temples. So one of the common principles found in Hindu temple spires is circles and turning squares theme, and a concentric layer design that flows from one to other at raises towards the sky. For example, we just draw a square. This is a perfect square which you are seeing at the bottom. I'm sure you are all able to see the square at the bottom. And then you just have to rotate. So you can rotate it by 50 degrees, 30 degrees, 45 degrees. Slowly, you can increase by 15 degrees. And then slowly we have increased by 30, 45, and 75 and then 90. Now, these are the only I have. You can see, apart from the first square, I have added only 3 squares. Now, most temples can also have 6 and 9. So they go with 1, 3, 5, 7, 9. And these are all oriented towards certain directions. And this also gives us the geometrical stability of the structure. And this is how they reduce the size. And they have a concentric one concentric point at the center. And they also actually scale these edges. If you reduce this, then our accuracy of building of any of these temples to be 100%. So that mathematical precision they have worked. And if you draw this, this is a perfect circle, you'll have this one. So this is, once we understood this thing we have applied for circles, we have observed, but applied it for squares, we have also applied it for triangles. Now I have not included that in our presentation because we still are trying to develop certain facts related to the modeling of these temples. Once we are able to, why are we trying to model? Because when we are trying to model, we are trying to understand the load flow of these structures and what could have been the method to construct these things. So once those are taught, once this is understood, we have applied the same thing to the modeling. I'll show. Now, most of the, I will not be able to tell or discuss the answers for such kind of things, but definitely I would tell you 2 or 3 facts about this. There is Brihadeshwara temple in Tanjore, and you would have found YouTube has a lot of reasons that this temple does not have any shadow. And there are a lot of other temples similarly, like there are hundreds of temples in Tamil Nadu and Karnataka, even in Andhra Pradesh and Maharashtra. A lot of mysteries have to be unsolved. But very less research in India, very less research is focused on heritage structures and to understand the science and engineering behind those. So Brideshwar temple is one in Tanjore. And then we have a musical pillars, Vitala temple and Hampi. And then even now, I think we have, there are a lot of people in Tamil Nadu, a lot of people in one of the company of our friends, they were trying to find people who can carve with stones and they can make a multiple music out of stones. But then still we are very much unsuccessful in this one. But they might have been used, what kind of technology they would have used in such a way that all these are make different sounds when we hit. And how could have they making hollow on certain stones without cutting it? There are some stones that are hollow, or have they found some kind of a stone in some kind of a quarry where the stone itself was a hollow? That was a very big question in the scientific community, and still it is going on with this. This is 10 facts to think. And hanging pillars. So there is one, there are not multiple pillars. This is in Veerabhadra temple in Andhra Pradesh. There were also other couple of temples in India where the column is used as an hanging pillar. Now we know that most of we know that in the current scenario, we always have our columns to transfer the load to the ground. But what could have been the reason? Was it the settlement of the foundation? But if it was the settlement of the foundation, there should have been other pillars as well. So was it actually designed in such a way to tell something else on this hanging pillar about the nature or nature devastation? So there was one temple we have visited very recently, Yaganti. So in that they actually say if the water flood is nearer to the Nandi's head, then there will be the destruction in almost all the surrounding villages. But there are a lot of such kind of stories which are there, which we are trying to understand. I have visited one temple that is in Gutti, and I have we are not given permission, but we have entered a little. But the tunnel radius was more than 2.5 meter radius. So there was a tunnel in that temple, and which actually goes almost 100 kilometers it seems. But we were able to go only till 300 meters, not even 300. I think 150 meters inside. Lot of insects, lot of other things were there, but we still have to explore the temple. So at that point of a time, we also have almost 5 meter radius of tunnels which were there without any PBM which was used. And at places, even there is a saying that there is a tunnel between the Charminar and Golconda in Hyderabad, and where 7 horses can go in a line. So what could have been technology they have used to have such kind of a fine tunnels? So that's another thing. And this is, if you see this image, they were all made up of monolithic stone. Monolithic is single stone. How could they have been so perfect in carving such precise dimensions? Anybody who have visited, you can just take a picture, or you can just take a scale. And in fact, we are trying to use image processing in this, and we are trying to see what is the accuracy using image processing. So image processing will tell the correct shapes and what are the curvatures to an accuracy of 1%, 2%, 90%, 98%. So we were trying to understand that. So you can see the entrance of the temple, how precise it is, and you can see the craft or workmanship of those people. Now, the question is all about this. I'm sure you would have already seen all those temples and would have been there. Now, I have one generic thing to tell you or to share with. What is the instrument or tool they might have used to get such kind of a precise? Now, if you see, if you go to the any of this Tamil Nadu, Karnataka, even in AP also, we have people who are carving the stones right now to build the new temples. So they use the stone cutter, or they use the blades, they use the polished stones, diamond cutter, to get the precise finishing. Even then, we won't get the very precise finishing of the stones. In fact, we are largely going with POPs and other thing to get excellent shapes. And this is a water cutting. They use the high pressure water to cut the exact shape. And this is the love shape. So this is actually cut by the water. So the water gives a very fine finishing of the stone, But if you see, why did I keep this picture? Because if you see this one, the love shape, it can only cut the exactly linear. You will not have non-linear kind of cutting. You will only have the linear cutting. And then you have other cutters. But then if I tell you to solve a Sudoku puzzle without teaching you the numbers, or any that those numbers, we will never be able to solve that puzzle, because we don't know the basic fundamentals of those numbers. Only if we know the numbers, we can solve the Sudoku puzzle. Same way, what if we are missing one of the kind of a dimension of engineering, and that is Dhvani engineering. Very olden days, we were very rich in Dhvani engineering or a sound engineering. Now it was also found in ancient and during pyramids in that cut. So how the ancient cut the stone with sound, and sound is one thing which can cut in a spherical and which can cut also have the non-linear way of cutting. So how did that sound engineering vanish from our culture, that we are not able to understand? So until and unless we understand the multiple dimensions of water, cutting with fire, I'm sure you know the welding part, you also know the fire with cutting, and you also you should also know the sound. With sound was can also be used cutting. In one of the, if you would like to test, I'm sure, don't try at home, but one of the song when they were actually taking for Michael Jackson, they were actually using the high bass and they were trying to blast the glasses. You put very high sound, then also you can break the glass. And there is another concept, you can use resonance. If you purely understand the resonance concept, then also with resonance also which can break. So all these things have been banished. So we are not able to understand the ancient engineering, because we missed certain dimensions of our engineering right now. But civil engineering, when temples were built, they used to clap and they used to make other kinds of sound to define the geometry of the temples or ancient structures. So that is largely missing. Today we actually go with aesthetics. So that's part we have seen, and we have tried to imbibe into our research. And one of the research was Thousand Pillar Temple. It's there in Telangana, India. And this is what column is a wall, complicated arrangement, layered construction. Thousand Pillar Temple, one of the unique thing about this temple is this is also said to have an ancient kind of a technology which was used in these structures, and that's called sandbox technology. I'll throw a minute on sandbox technology on coming slide. So you can see the columns as well. This is completely black granite. So they've used a lot of granite, and this is, and one of the professor Pandurangara from NIT Warangal, he has been heading the heritage of Telangana, and he has been worked a lot on this. In fact, he was one of the person who has leaded to rebuild one of the mandapam. So he has removed all the stones, and he was very successful in rebuilding one of the mandapam of this complex geometry. Not the temple, but mandapam, one of the mandapam. You can see layer construction. Layer construction is one of the good thing for any kinds of floods, and also for earthquake resistant. So you can see this, and Golconda Fort. one of the best part of Golconda Fort was, if you can go, this is all stone structure, complex kind of a in engineering. But yes, there is a way how they have built. Here also we have seen in the ground floor, we have a single stone. It goes and it breaks into two stones. It's not they break, they put two stones, and on that they put three stones, and slowly they increase and transfer the load into a single stone at the base. So that we have seen, and very recently we have been able to match the kind of construction of different kind of structures. So in this, why did I keep two pictures is, in the ground floor, in the bottom of the Golconda, it is on a hilltop. On the ground, on the base of the hill, if you clap, you can hear the sound on the top on the palace. Now you won't be able to hear this clap anywhere in between the path from the bottom of the base to the top. It we can only hear in the palace. And they have used a concept of resonance. So you clap here, this will resonate, and very similar kind of structure was built on the top, and that can resonate, and immediately there is kind of a communication. There is no need of people to transfer, people to go through that. That's the unique of Golconda Fort. And of course, this is in Odisha, Bhubaneswar, Konark Temple. There is no idol in the temple, but they were able to design the whole day of the clock. So there are what a person does in a day, and how it will be there in a year, month, week. It is there for a day, 24 hours. It is there for a week, and it is there for months, and it is there for a year. Everything is crystal clearly carved. But still, we are still not able to tell very precisely what exactly they would like to tell on, exactly what to tell what is happening in months and year. But yes, precisely it is done. And carving is also very unique, and it is also precise to mm. Numerical model. So once we understood the basic facts of the geometry and mathematical, we started with a very simple. I said this is by a hand sketch. And then why we were trying to understand also the role of other geometrical aspects on if there is any change because of the geometry, will there be any effect on the load transfer? So what we have did was we did image processing through this. We take an image, we scale that image, and then we were generating the 2D images first with a pencil, and then we were trying to use it in the computer to generate a 3D model. Now, once we generate 3D model, we are also trying to do the 3D printing of these structures to see what, with 3D printing, we have an advantage. How could they have been constructed? So that kind of thinking which we can do with the 3D printing as well, which is a little advanced stage of this. So this is numerical model of one pillar. This is second kind of a pillar, and third kind of a pillar. Now, even though when I say all these things, one thing is for sure. In spiritual, they say all these temples are for energy transfer. So if somebody goes and sits in a temple, they can actually feel the positive vibe, and they'll also attain certain kind of an energy. That's why we will visit temple in the morning. But there is also another thing to this. There's a tradition, there is a culture, and there is a knowledge they would like to transfer through these structures. These structures are also an ample reason, an ample to tell that there's a lot of knowledge which was present in those days, and they wanted to transfer this knowledge through these structures. So that might be in terms of engineering, that might be in terms of the facts of the nature. And this is numerical model of mandapas. These were little complicated mandapas which are very difficult to understand how they would have been constructed, but simple mathematical rule I have said, or what we have discussed earlier, like a simple square, rotate it, or a rectangle, rotate it, or rectangle concentric, we were able to model the complex geometries of this. So this is the Mandapas, Vitala temple. You can see the mandapam. And the first, this is very rough diagram. Way back, 3 years back, we started. Very, very rough sketch of this one. I'll show how precisely we have reached till today. And this is Thousand Pillar Temple. Excuse me, just missed one picture. So you can have this perfect squares and rotating concentric, and finally the circle. You can see here, and you can see the square, and you can see the rotated square and another square, and then circle on this. And each one accidentally, this actually tells one of the dance people used to do just before going to the war. in that culture, in that tradition. So each image replicates the one of the step of such kind of a dance. So this is seen on Thousand Pillar Temple. This is also seen on Ramappa Temple. So they actually show the hierarchy of people in that society. They also show what kind of traditions they had and the kind of tradition they used to use for just before going to the war. It's all embossed with the scriptures. And this is very raw image of what we were trying to do at the beginning, as I said, in 3 years back. And this is Lotal Mahal temple. This is also a multiple, so you can see the kind of concentric squares and the non-linear of kind of arches. So we were very successful once we understood that Lotus Mahal and all the concentric circles. We were almost precisely able to develop 90% to 95% accuracy of this model. But again, I'm saying the only point of all this modeling is only one reason, that when we model all this, how could have they placed all this as a layer, or is it actually made up of a single stone? All we were trying to understand. This is made up of stone bricks, and finishing was also lime. You can see in this picture. And this is the numerical modeling of mandapas. This was basic gravity analysis, and we also wanted to understand all the structures where they're resistant to the lateral loads, because these days we have something called earthquake analysis or wind analysis or impact analysis. We should talk about a lot of other analysis, and at that point of time they never had this system, but they used to have they have to build is some locking mechanism kind of a system. And in Ramappa temple, of course, I think I have a picture. They have melted the metal and they might have poured into the hole of the stones for the locking. It's not the steel they have actually kept at the beginning. And this is the precise which we have reached today. So in the last lecture also, I think I shared numerical model of mandapas. Now with the image processing and artificial intelligence, we can cut the different sections of a column, and that section can be modeled and it can be used. So for this we have used Autodesk Inventor, but AI can be implemented, and this it can be tell how many number of different kinds of geometries were used in this one. Here also there were little animals, how they were taken, how they were, that is also carved. And if you see here, the best is the preciseness of the column. You can see that is in the fourth. You can actually put the little finger just below that. So that was the precise of that one. And there are two joints in this stone. So one is, and this is the perfect model and with analysis. Of course, general analysis doesn't give much of any kind of decrypt of any mysteries, but it is that actually has a lot of stresses at the bottom and decreases to the top. And if it is not loaded, but it is loaded, of course, it's uniformly stressed up. And this is the complete 3D model, and this is the complete 3D model of the 1000 pillar temple. Of course, it took us almost 7 to 8 days to render the complete model, and it took us a lot of time. Again, as we were trying to understand 1000 pillar temple, this is only a superstructure. And one of the big thing about this is the basement, because like 400 or 500 years or 1100 years to have such much a huge weight at certain place, they might should have been used certain kind of a technology where it has not seen any kind of settlement. Now this is analysis. Of course, the mid part was having certain stress and displacements of almost negligible. Is this? So here I would like to tell for sure. This is also in the Warangal state. This is 1000 pillar temple, and this actually had something called ancient sandbox technique. And all this here, this is the temple where they have also found the floating brick. Many of the scientists or many of the engineers, many of the people who have did extensive research and materials have tried to decrypt what were the components, constituents of this brick, but till now we don't have any answer. This is the only brick which weighs and which actually floats on the water. So Ramappa temple has got this small temple where bricks were used. Apart from the sandstone, you can see all the sandstone which were removed. This is all removed, and this is place where there was brick, and this is the only temple where we have seen bricks. on the top for finishing, apart from the actual temple, and these bricks were floating in the water. So still, I think if anybody is visiting Warangal, I'm sure if anybody is from Warangal, they would have seen it. Still, it is there. You can see that. So as I said, Professor Panduranga Rao from NIT Warangal have actually read a lot of this. Now at the bottom part, now you can see this kind of a small kind of settlement here, and you can see the slight change in the bottom part. So this they have actually used sandbox technology. Let me tell you two things. So sand is one kind of material which can allow the water to flow with it without much of shrinkage and expansion. That is why whenever we have a very soft soil like clay, we add the sand so that we will actually decrease the shrinkage property of that. So here the whole temple, below the temple, they dig a very big dig. They have excavated and they have made like a chamber, a very big chamber, and in that they have poured the sand, and on that this temple actually has constructed. The three beautiful things about the sand is if the water gets in, it gets out without changing the bearing capacity of that one. Since it is confined, the soil has to be confined, it should not be open. If it is open, there's a lot of liquefaction can happen. This is what the Taj Mahal might be in the future, because it is on the Ganga rivers, and Delhi is the earthquake prone area, and if there is an earthquake, if this is not confined, then it will actually undergo liquefaction process. Okay, so water comes into the top and it loses. But this is Ramappa temple, the weight is so calculated, the foundation is so calculated in such a way that even water flows will go out without changing the bearing capacity of the soil. So with that, this structure will be stable for the floods or any kind of river. And soil is another good thing is, if there is an earthquake, the vibrations will not reach the core structure. That's another advantage of soil foundation. So this was very similar kind was also seen in other civilization, one or two, but it is not the exact of sandbox technology, but they have used layer construction. So one is this has been decrypted long back, and the same kind of foundation might be used for new Ram Mandir temple. That is also has been now it is been constructed by L&T. They are thinking of sandbox technology. Now reason is why we can come up with a huge concrete and the age of concrete might be hardly 100, 150, 200 years. We are not able to go beyond that. But stone with the sand is very good at silica. You leave it for 1,000 years, nothing will happen to the stone and sand. So that's why they would like to use such kind of a foundation so that can be stay for thousands of years. Now for that, of course, we did simple analysis in our lab by taking different types of sands and soils and sand, and then the same thing has been actually published in one of the paper which we have presented in Euromed in Europe. This is there are two other things which we have found in this one is you can also read in UNESCO paper. This is all sandstone. We have a black granite. See here, it's like a bracing here to actually have the large portion of 5 to 6 feet of cantilever. So this is there all the sides of the temple. And one good thing is this is the stone which we have. There are multiple stones. They might not have used the rods at the beginning. They might have melted and poured for the locking mechanism. These are some stones which we have seen sideward. You can also see the stones here. This is where unfinished stones. There are certain numbers, but there were also some unfinished stones which were seen at that. So this is more than 500 or 600 year old, but nothing much of history is there on this. And you can see the settlement. Whenever we would like to know what is the condition of foundation, only one visual inspection can tell whether it is stone structure or masonry or steel structure. Is what we see is the settlemental cracks, and these are all the attachment. These are all attachment of different stones, and we actually seen there is slight settlement of foundation here. Hopefully this will be renovated soon, since this is already there in UNESCO World Heritage Site. I think here in this picture we will not be able to see. You can see the kind of carving of this pillar, and there's also one pillar which was actually inclined. Actually, I don't think I have have in this slide, but it's okay. But anybody who actually can visit, if you can visit Ramappa temple, you can visit. There is also a museum there, you can visit. You can also see the floating brick. Once this is already there in UNESCO World Heritage Site. Now this might be renovated soon. This is what I was talking about, the foundation part. These days we don't use sand for the foundation at all. But maybe in soon we might come up with certain kind of a sandbox technology kind of a foundation for earthquake resistant structures, especially in the northern part of India, northeastern part of India. If at all, if we are trying to go for masonry structures, this might also be good for RCC structures as well. But before we conclude certain concrete thing on that, a slight experimental testings have to be still done on that one. So I was telling about these carvings. There's a lot of history. Every column has got certain story to tell, and no two columns are exactly the same. Carvings are different. Even the geometry seems to be similar, but carvings are very different for each column. And this is what the testing we did in the laboratory. We're trying to find the liquefaction process, and we were also trying to find the vibrations, if at all, if we have a sandbox technology. This was the team which we visited in 2018. We had it's not only civil engineer, we had civil, electrical engineer, also computer science we have visited, and we were trying to did research on it. And there's another thing which I have also discussed, but one of the most important thing is India has got more than 2,37,000 villages, and every village has got unique culture and unique material to build their houses. And every village has its houses which have been evolution and which actually describes the science and engineering about those structures. So since because of the so-called modern materials, all this knowledge has been perishing. So what we did was we started one project. We called people from all over India to build the structure in their village with such kind of a material, but scaled and to be presented at Mahindra University. And then we wanted to convert this into a digital form so that that knowledge will be saved. So now we are visiting a lot of village houses, and we are trying to write science and engineering behind those village houses and trying to save that in a digital form. So we were very happy when we have seen houses from Gujarat, Gunga house, Ganukettu house from Kerala, there is Metta house and Tathara houses. There are different types of houses which were brought into this campus with the scale. And then we were very happy to see. And the astonished thing is they were all built with local materials which were available very nearby, and they were built in such a way that those houses actually resisted climatic conditions and extreme devastating conditions of that region. Still trying to figure it out why we are not able to go back to that such kind of a traditional materials we know which are sustainable. But there is also a lot of relation between these structures and heritage structures as well. That's one of the reasons why I added this slide. So this is modeling. Right now we are not doing the modeling point. We are trying to go back to the point clouding, point cloud, where we try to take thousands of images of this building so that you will actually have the real, not the modeled one. So this modeling, it took us a lot of time because we have to be very precise and giving all kinds of texture so that it actually looks like a real building. But then one of the professor from IIT Jodhpur, he said that it will be good if you can use LiDAR and other advanced concept to share or save this knowledge. So when we have such kind of 3D models, all you have to do is we just have to take this app which we have built. This is the actual house, the left one, and this is the model one, and you just need to project on this book. If you rotate the book, you can rotate this model, so you can see this, the rotated model house, and you can actually zoom in. You just have to take book towards you, and you can zoom, and you can also see the interiors. So you can see the kind of material, you can also see the kind of engineering which was used to build that structure. So this is one of the house in Himachal Pradesh. Very good structure, also earthquake resistant because it has internal connections and lateral loads can be divided into layers of this structure. And this is the Tatara house which I have sold, and this is 480-year-old. This is also there in Himachal Pradesh. Today we tell if the structure have to be earthquake resistant, then we should reduce the mass on the top of the structure, but unlikely, This structure has also resisted, it has saved itself from 7.8 magnitude in Himachal Pradesh. So 480-year-old, and there is a lot of mass on the top. Yet it has restricted. So you can know the kind of engineering they had at that point of time, and it was built with only wood, and as well as they had wood and stones. But the best part is they had certain kind of a dampers at the corners which can actually transmit the vibrations to the bottom. So this we have modeled. Maybe in one of the other models, maybe I'll show that one. So here we also use something called zoom in, zoom out, or rotate. So we have been trying to come up with certain technological aspects where you can actually get into this building and see. So the next will be the real buildings. And of course, with this, I would like to stop at traditional structures, but right now, conservation is another very important. For stone structures, we were trying to see the settlement by the pointing or cracks or the undulations or deformations. For lime as a conservative material for heritage structures, lime has been used from thousands of years. So I'll tell one example, which is ongoing project. This is Molali, which is there in Hyderabad, very nearer to the place I am. That is why I've taken it very interestingly, and we were volunteering about the conservation of this structure. And it has got a history of 400 years and old. And these are all commands. Let me not tell those names, but I'll not confuse with the names, but we have taken these two commands. So you can see this, and you can see the right one. The left one, since the person who is the owner of this, he was living in, this is owned by Al Kausar Trust now. Since nobody cares, there was a family which was living in this this tower. This is the command, and they have actually fixed these doors. They have closed certain openings, and they have actually built certain bricks and other stones as well. So we had, when Alcocer Trust took, they wanted all these commands to be conserved, and they wanted to make and bring back to its original geometry and original condition. And there was also a lot of fountains here. So they wanted that. So we went there, we did the study there, but I'll only show a few pictures while we were doing some testing. And this is, you can see the all the broken, and there was no maintenance at all. In fact, there is a bad maintenance here, but there is a completely no maintenance. This was completely built with granite stone and plastered with a lime and red mud, lime and red mud, not with the sand. And the thickness of that lime was almost like 50 to 75 mm. That a huge thickness. 7.5 centimeter is not a short plastering. And this is whitewash. They have also certain years, I think every 100 years or 150 or 70 years, there is one festival. So during that point of time, I think, so every 50-60 years they have actually used whitewash, and that's why the thickness of the layer is so high. So we have also seen certain stones have broken, and there are certain places where cement was used to conserve. Now you can see also the crack in this. So crack from ventilator opening to the arch tip. So, and the repair was done with the cement. So now what we did was, if there was a crack, we wanted to know whether it was a stone crack or it was just a crack on the surface. So now when there was a stone crack, we drilled the stone, and there was a rod which was kept inside that, and plastering was done. You can see the bad maintenance and the chip off. You can see that the actual design is this, and the design has gone, and you can only see the granite stone. So there are certain places where there was a single granite stone which is of square size, and there are certain granite stones which are of in a flower shape. So both kinds of was there, and you can crystal clearly see this is the method of arch, keystone arch. So there was a keystone which was used for all the arches. So this is the arch of window. We have removed that, everything has been chipped off. So this is plaster chipped off, replaced on cement plaster. Now this is closed ventilator. For family to live, they have a closed ventilator, because on the top there are huge winds, and winter it's too cold. And a lot of repairs were done with cement. As I said, this is what also. Now when we went, there was all chipped off. So we have removed all the whitewash, and you can see this. And this corrupts. And this is the fountain. Fountain was completely filled with mud and laid. They weighed Betam Cherla stones, Shaba stones, and you can see from the side view. So this, when we went, we told to remove all the upper layer. Of course, we had an estimation and we have given to them, and then we're part of that. So you can also see slight cracks on the column base. So this is what I was talking about. Now this is going on. Completely the upper layer of the complete lime was removed. Now we are actually going for 15 mm of coarse, another 15 to 20 mm of fine sand, and finally it's another 6 mm to 7 mm of fine lime. So we had one of the person who belonged to the family of Charminar, and we found the lime mixing. They store lime for 1 month of fermentation of the lime. They mix, and we also use different materials, which I'm going to show. So you can see. So you can see certain places where they have filled with the red mud and stones. We have removed everything. You can see on this. So this scaffolding, you can see the person actually using tapi. Tapi is just used for cement. So actual lime, they use jute bag to finish that, not the tapi. With tapi, we won't get exactly. Now, if there is a procedure to finish to get the old layer, so at certain places we have to go even for 75 mm. So for 75 mm, we were getting the shrinkage cracks. So we cannot have more than 15 mm at the same point of a time. So we have to go 15 mm, 15 mm, 15 mm. And you can see this. We have fermented lime, which is actually mixed at the site, and then we have used, and you can see the kind of finishing we were trying to get at that site. And this was one wall we tested first how good finishing we'll get without any kind of shrinkage cracks or cracks. So we have to left it for a month, and we had for 2-3 months. Now this is almost 6 months. We have not found any crack on that. Now the final coating of this is been done, and you can see the complete stones. So wherever there are voids, we had to grout with an injecting with the lime mortar. So lime mortar, we were not used any cement at all, the completely lime mortar granite. So wherever loose mud was there, the completely that was removed. So in one of the most important thing in conservation is we were not supposed to use any modern materials. Why? Because any kind of a modern material will have only 50 or 60 years like cement and all, and they will be peeled off and they'll be spalled off. So we wanted something which can go for 300 or 400 years or 500 years, and we found lime is one thing. And we take up this lime and we tested in our lab, and we have actually casted almost 150 cubes which are kept in our lab. Now that cubes we will be testing for over a 5-year period of time, because lime is one such kind of a material. Even in any, I'm sure if anybody is from Archaeological Society of India or who has been in the conservation of heritage structures, they would have known lime is such kind of a material with a proportion. The strength of the lime can be increased over a period of time. Calcium carbonate it forms over a period of time, and the strength will be increased, but only it depends on the composition of lime. So what are the composition which we were using is this. We were using jaggery, we are using jute fiber, and gallnut, and this is egg white, not the yellow color, only the white, and this is the mixing. These are all done at the site. Now we have the site where we actually mix all this at the site. One of the challenging here in Molali is to take the whole material to top. So the work is going very slow from past 2 years. So good thing about jaggery and gallnut is, see, these are organic material. When they are mixed with the lime, over a period of time, organic will slowly vanish into the atmosphere by the compression. So they actually shrink in very small, but close all the voids. When you close all the voids, it's actually high. It becomes the higher density, and it will also stop the deterioration of that. And the best part of lime is when it reacts with the carbon dioxide, it actually becomes a calcium carbonate, and actually becomes the strengther and strengther and stronger over the period of time. Jute fiber is whenever you have, whenever you use pure lime, it will shrink. So if we are going for 15 mm and 20 mm, then we mix with jute fiber so that we actually avoid the shrinkage cracks. This is the mixing at lime site and the application of first coat, and you can see the single stones on the top. So this is also single stone here, and then this is also single stone. In fact, we have taken the images of all the stones and we are trying to understand the arrangement of all these stones, and we were trying to compare with different structures which were built in that era. And we have seen every era the structures were built, the arrangement of stones have changed a little. So if you see now this in conservation, the most important we are trying to see is the arrangement of stones, replacement of stones. If there is any crack here, as I said, we were grouting that and we put a steel rod on that one. Of course, because there is no other way, because it is highly difficult to remove the stone and replace the stone. And if you want to know, there is only one or two NDT tests are there. One is thermographic and second one is flat plate jacketing test, where you will know the load or transfer from stones. We didn't do anything of that, but we were trying to avoid maximum replacement with a minimal to conserve this structure. So this is application of first foot. So anyway, this is we call it as Egbhara, and we have something called Dubhara and Sivara. I'll just tell the concept of this one is Egbhara is the first. We actually have the coarse metal coarse sand with the lime, and we use jaggery and gallnut is actually mixed with that one, and we can go with till 1.5 centimeter in one coat. More than that, we'll have shrinkage cracks. And again, Dubhara, we are going for almost 10 mm, and Sebara, we are actually going for 4 to 5 mm. So this Sebara is one where we use egg yolk. Egg yolk is not used in Egbhara and Dubhara. So we are using in Sebara. So in this one. Oh, 1 minute. Did I think something happened? Okay. So anyway, this is the conservation. So what I would like to conserve, I would like to conclude this one is, so we have tried to understand the science, engineering, and conservation of heritage structures at various dimensions. So one, I told you that we were trying to understand how the sound was used to cut the stones such precisely, apart from the water cutting and other cutting. And we have also found a way, maybe soon, maybe down the line of 2-3 years, we might come up with a way how to cut the stones in such precise way. We are trying on it. And the second one is, I have also shared how we were trying to understand the foundations of different temples which were there lasting for hundreds of years without much of settlement. That's called sandbox technology, and which is also known for earthquake resistant. And third, I was trying to tell the actual structure where we were trying to understand the properties of lime, and we were trying to test the lime and how the lime is being used at a site where the site can be conserved for another 400 to 500 years of time. So this is what we did. And in conclusion, I would like to tell one thing. That's all one era. Now the whole country is looking about digitizing all the cultural heritage we have. So we are trying to take thousands of image of the actual. This is the actual one. So this is before and after. Okay. So this is the digitization of structures where we take thousands of image and we don't model anything, but we rebuild all this with the live images so that you actually feel the live site. And you can zoom in and zoom out of these structures and can see how they were, what are the kinds of carvings which were there, what are the kinds of paintings which were there, what is the kind of fineness of the finishing. Everything can be said. This is how we are going in, and this we are really working on it. And if you take the point cloud, this is how you can see the real heritage structure. So conservation is not only done at the site, but conservation is also done at technology site, where people might have difficulties in going at that site, but still visit with using a simple Microsoft HoloLens sitting in their home, and can then zoom in and zoom out and can understand the whole structure sitting at one place. So this is another area which we are traveling into. So this is where I would like to stop my presentation. I hope I have not not given any other information. I have tried my best to give you the very small thing which we have did, but which is trying to change in a very big way. So lime that we are using now, conservation of many structures are happening with such kind of a lime. In fact, a few of the residential people also have asked us to use lime and have this one. We are also using for certain farmhouses where they are designed in a very much into considering into heritage architecture into that, to have that heritage look, and completely sustainable, no side effect. In fact, it decreases the carbon dioxide which is released. So again, from this, if you have any questions, you can actually have it in chat box or you can ask. Thank you so much once again for this opportunity. So if there are any questions, I can actually go with it. In fact, I always say our journey has just begun and we are putting all the efforts. We have a team of almost 20-25 people who are working, trying to come up or decrypt certain things of heritage structures. So for better India. Okay. Yes, if there are any questions, yes, I'll take up. Was my voice audible?
Yes. Anjali?
Okay.
Yes, sir, we have got a set of questions. The first one is, can von Mises stress analysis be applied to brittle materials like stones?
We have actually seen von Mises stresses, but in stone we have to understand that is a brittle material, and we have found that those results are not much of useful in our analysis. So we are trying to, with sensors, we are trying to find only displacements of stones in 0.001 mm to find the settlement of the structures. Von Mises stresses, yes, they will give you certain picture, but till now for us they have not been much useful to us. But in bridges you might have stone mass in the bridges of 41 or 50 meter high in India. There we are trying to use von Mises stresses. But right
thank
now,
you, sir.
yes, please.
The next question is, if bricks float on water, what is the specific gravity of brick material?
This I'll certainly I will not be able to answer this because that brick composition, there were people, I'm sure they were trying to build that brick with gobar, like cow dung and all. They were trying to mix, and they were also trying to mix the dry grains, husk and all to make it. Definitely, it is specific gravity have to be less than water, otherwise it will never float onto the water. So specific gravity is definitely less than the water. It is floating in the water. And examples are, the actual material is still there in Warangal. You can visit and see. So specific gravity is less for your question, but we are still not able to know the composition. People are trying to do the XRD. I'm sure you know the XRD. XRD is we X-ray. In such find, we will try to understand the micro level of materials which are present in that. Maybe with the technology goes on, we might find the composition, but till today we don't know that.
Okay, thank you, sir.
They are like bricks.
So the next question is, why can we see only monumental structures remain and no other like housing, etc.? Any view on it?
A simple answer for this: all monumental structures are built with stones, and stones have ages of thousands of years. And remaining all other structures might have been vanished because of the natural disasters, or right now we are going for advanced materials. We are actually removing old structures, so that's also space. So olden structures had the basement or a pillar thickness of, you can see, even 1 meter, 2 meters. So monumental structures are still present only because of the material and very low of weathering. They won't undergo huge weathering. So that's the answer I would like to tell for this question.
Thank you, sir. The next question, what is the role of egg yolk in conservation? Calcium content or something else?
Yeah, like jaggery is one kind of a material. See, whenever we use jaggery shell and all, egg yolk and all, yes, a little of that is always restrained with lime. And another property of that egg white, what we have seen is the finishing of that is excellent. The shiny or glossiness on that material is always seen. And it will allow the organic material will allow the breathing of the calcium or lime, which actually inherent builds its strength over a period of time. So organic material will breathe. If it is an inorganic material, it will not breathe. So you have something so that lime will breathe. Lime has to breathe. If anybody is actually using any kind of a new emulsion paints on a lime, then believe me, that will spall within years of time, 1 year or 2 years of time, which we have did very big mistake in one of the conservation. We used lime and we have used emulsion for waterproof, and immediately within 1.5 years we have seen the spalling of that lime. So a lime has to breathe to become stronger every year. And egg yolk and any organic material like jaggery and gallnut, they'll not undergo any kind of reaction, but they'll make the structure to breathe. That's why we add organic material. In fact, in one of the European countries, they also used blood. So most of our structures become non-vegetarian in that way. There's a lot of literature on that. Yes, that's for breathing purpose and for glossy finishing.
Okay, thank you, sir. So the last question: is there any prevailing design base for heritage building?
I said design based. I did not get that question. Right now, for heritage structures, simple. If anybody is asking me how to do design of heritage structures, I'll tell simple mechanics, equilibrium of equations. Only convert your forces into different directions, and then we design using very simple mechanics. Simple mechanics. You don't really need any kind of a code book for masonry structures. For concrete and steel, because we need sections and a lot of research has been done, and the sections have been very optimized. That's why we need a lot of code books. But for masonry structures, it is a very hard thumb rule that we use basic mechanics to to design the structures. Now we are working on certain culverts, and we are recommending Indian Railways that certain culverts might be used. We don't really need to replace by saying hundreds of crores. In fact, this has happened. This is happened in very recent weeks. So simple mechanics will work with the masonry structures, but you should really know the material property, the density of the stone which you are using, and the amount of load it can be taken for scaled size, so that you can actually tell how much load the whole stone can take. But ANSYS, Abacus, or other softwares which can help you to model and tell us whether those structures can be stable or not. FEM based softwares you can use for masonry structures modeling.
Okay, thank you, sir. That's all.
Okay.
Yeah, Anjali, shall I propose the vote of thanks?
Yes, sir. Yes, sir.
I would like to tell one statement, and then I'll so again, just before concluding my session, I would like to thank ICI Mangalore section and QCrete for giving me this opportunity. And whatever I have presented, a great work has been done by our team. Special thanks to our team as well. And special thanks to all the participants who have been very patient in listening to this lecture. Most welcome to send any questions to QCrete, and indirectly I'll try to answer if there are any other things. Also, if there are any mistakes, please you can always send a mail. We are always open for improvements of our work. Thanks again. Thank you so much for this given to the panelists. Thank you. Thank you so much.
Thank you, sir. Thank you very much. Good evening, friends. We have come to the end of our another interesting topic, science, engineering, and rehabilitation of heritage structures. I thank Dr. V. Dilip Kumar for delivering a lively talk on the topic. Thank you, sir, for the eye-opener talk. We still have a long way to go in understanding the science and techniques behind the heritage structures as we were going through your wonderful lecture actually. Thank you very much, sir. Once again, I thank and for all the interesting way you had put the talk for us actually. I also thank ICA Chairman, Secretary and Treasurer and entire executive team of Mangalore ICA Center for associating with the QCrete webinar series actually. And I'm Shelly Fernandez from QCrete Readymix India Private Limited, signing off till we meet again for our next topic in the QCrete webinar series. Thank you all. Thank you. I thank all the participants also for the this one for attending our webinar, regularly attending the webinar series. Thank you all. Thank you very much.
Thank you. Thank you.